Here we go. All right, so we're going to just quickly review how to construct linear, quadratic, and exponential regression models. So those are our main three, correct? If you are using Desmos, I'm going to write out the models for you to use in Desmos. Got it? So if you are one of my Desmos people, so if you're using Desmos, you have that the rules to write out. So that's going to be your Y or not. Y, there we go. Y, and then, so Y1. And then for linear, what else do I write? Anyone else remember in Desmos? Y1 tilde mx1 plus b. And that's going to be your linear. So if you're using Desmos, you got to remember that. Okay. Quadratic is y1 tilde ax1 squared plus bx1 plus c. And that's going to be your quadratic. Your exponential is y1 tilde ax1. I'm sorry. I didn't mean to put x there. A, B, x to the 1. And you have to make sure you check the log box. Okay? So make sure you check the log box. This is if you choose to use what? Desmos. Okay? If you choose to make your regression models in Desmos, you have to remember these. All right. Do we remember these? No one's like, I've never seen these before. Yes. Okay. I'll take it. All right. So let's dive in. Yeah.
Why is there a check mark?
Because there's a box that you have to check so that it's giving you the same regression model that you get in a handheld calculator. So you got to remember to check that box.
Okay.
Good. All right. So, you're going to pick your poison for how you want to do it. So here we have Darren, who injured his hamstring in a football game. His sports trainer sent him to the physical therapy to build up his leg strength by using a regulated weight machine. The table and the graph show the number of repetitions he has been able to do on each day he was in PT. The best fitting linear function, y hat, that's what that is called, y hat, equals 2 and 500ths x plus 4 and 95 hundredths is also shown. We can use this line to find the residuals, okay? So here, y hat just means that this is a regression model. So anytime you see this guy, that just means that this is a regression model. This is not the real, it's the regression. Okay? Do I need to go through the steps of how they got the regression model given a table, or are we good to go? Good to go? Okay. So this was the information they had, and from there, they got y hat, the regression model of 2.05x plus 4.95. Okay, that was their line of best fit. Now we're going to go back to the word residual. The word residual, we talked about in pre-AP Algebra 2. We talked about it last semester. Your residual is, that remember, we're going to rap about it. It's R equals your actual minus your predicted value, right? So your predicted comes from your regression. So when you're doing your residual on a mapping, you're looking at how far are my actual points from my regression line. Okay, how far are my actual points from my regression line? So like this one is perfect, right? It's right on there. This one is just like a little bit. This one's a lot. This one's a lot. And this one is like hard to draw, but it's right there, right? That's what your residual is measuring. Does that make sense? So your residual is measuring how far is your actual value from that regression model that you've created. Yeah? Easy enough? Visually? Okay? So if I have a residual model looking here, if it's 0, that means it's a perfect fit. So this one would be a perfect fit. Yes. So this is perfect. If it is a negative value, if it's a positive value, what does that mean? It's over. So here it's an overestimate, or how do I say this? I said that backwards. If it's predicted,
If it's positive, that means
it's always the opposite.
Sure.
Yes. Yes. I was like, am I saying that wrong? So if it's positive, then your predicted value is going to be a underestimate, right? If it's negative, that means your predicted has to be a overestimate. And that's where these lines fall. Okay. Whether it is under or over the value. And that's where your wrap comes in. Okay. Your actual minus your predicted. All right. The formal definition is written in the box for you, but I like to say let's wrap about it because it just helps you remember residual equals your actual value minus your predicted value. Residual equals what? Your actual value minus your predicted. When you say those things out loud to yourself, you will remember what wrap means, okay? You can stack them over there on my table. All right, so what I want you to do is you're going to go through and calculate the residual values, okay? In order to calculate the residual values, you're going to have to find my predicted values, all right? So we already know our actual. So we already know our actual values, right? Those are given to us. Now we need to find our predicted, our regression values. Okay, so finding our predicted value means that we're taking these x values and plugging them into that predicted equation that we got. Okay, what was our predicted equation? What is our y hat? That was 2 and 500x plus 4 and 9500, right? And 9500s. Can I find what those predicted values are? Yes? All right, so I'm going to give you a little bit of time and you're going to find the predicted and then find the residual of each one of them, okay? Go. All right, so by show of hands, how many people plugged in each value? Each value? How many of you plugged in the equation and looked at the table? Okay, all are correct. Either way, as long as you did something. All right, so for my predicted at x equals 1, what do I get? I still get 7, and we saw that from the graph, right? It didn't change. For my predicted at x equals 3, we got 11.1. What about for 5? 15.2. For 7? And for 8, 9, I can count. 23.4, okay? Now, to find your residual, that is going to be your actual minus your predicted, right? So our actual minus our predicted. So on the first one, which we knew from the graph, was going to be what? 0. We could tell that from the graph. On the second one, we got a negative 1.1. You just have to do the math. 7 minus 7 is 0. 10 minus 11.1. Yeah. Okay. All right. On the next one, so 18 minus 15.2, we end up with 2.8. And then 17 minus 19.3, we ended up with negative 2.3. And then on the last one, we had a positive 0.6. Remember, we said that was pretty close, right? Like when we drew our little red line, it was like very, very tiny, correct? Because it wasn't exactly on it, but it was very, very close, okay? All right, so when we were in Algebra 2, we talked about the squares. Y'all remember talking about the squares? Doing our little Desmos thing to try to make the smallest squares so that we would have the smallest values. Okay, the reason why we do this is that we square the residual to eliminate the negatives, okay? The smaller our squared is, our residual squared is, the better fit. So when you're trying to compare which table, which function, regression model best represents my data, I'm looking at which one has the smallest sum of squares, okay? That's how the calculator is processing that. They're like, oh, let's run these numbers. Oh, this was the smallest squares. All right. So here, when I'm squaring these, I'm literally just going to go through and square each one of these. So 0 squared is obviously going to be 0. -1 squared, a -1.1 squared is going to be 1.21. 2.8 squared is going to give us 7 and 8400ths. -2.3 squared gives us 5 and 29. And then 0.6 squared gives us 0.36. So your sum, so the calculator said that this is our best fit because the sum that it came up with is the lowest sum that was produced. Okay? Okay. They don't care. This will be stuck in here. The lowest sum that could be produced, right? And that would be 14.7. So after it ran all the numbers and all the things and moved the line to try to fit, this is the one that produced the smallest sum of squares. And that's why I decided that this is our regression model. Okay, yes? Yep. For the sum means you add. All right. How do you feel about doing a residual by hand? Was it terrible?
No.
No. So in Algebra 2, we talked about you can do a residual completely in the calculator, right? And you can find all your values, your sum, and all that good stuff in the calculator, and we'll get to that thing, maybe. So given the points here, you can see that graphically, you're just measuring distance, right? And distance, anyway, we want to look at it as positive, but the distance being positive or negative lets us know if we have an over or an underestimate. Okay. What this is called, if you take statistics, this is your y minus y, your hat. In this case, this is your residual, but in statistics, it's called, this is y minus y, which is that sum of here is your deviation before the regression. So like, what's the change? How did it change? But that is for statistics, and we don't have to really worry about it, right? You already did? Oh, yeah. So in statistics, that's what they focus on. In our algebraic classes, such as pre-cal, we focus on the residual, okay? Our over and underestimate. So biggest takeaways here is that we're measuring our error. That's what your residual is saying. How much error is this going to occur? Is going to occur based on me using this model. Okay, what's my room for error? And obviously, when you are measuring error, you want the smallest possible, right? And that's why we want our sum of our squares to be the smallest. All right. So here are our takeaways. The main thing, your regression is the line of best fit, and it's going to equal the least squares regression line. Okay. Your regression is your line of best fit. Okay. The residual, it's your actual minus your predicted. Okay. Your residual is your actual minus your predicted. Your error, however, let's see, is your predicted minus your actual. It's the opposite. Okay. The error is predicted minus opposite. So this is the biggest takeaway from here. All right. When you have a small data set, it is pretty doable to do it by hand. However, as it gets bigger, we do want to bring in technology. Okay. So if you choose to use the handheld, it's our stat, our edit, our calc, and all these good things. In order for you to be able to see residual plotting, we're going to go through those steps as well. So there's the pictures of it. So these are the things we're going to do to find the residual, and we're going to dive on in and do the steps. Are we ready? I need my mouse. It goes fast. Or I shocked you. I'm sorry. All right. So I'm going to open up Sylvie. You know, she's been taking a little break. Hey, girl. Hey. Wake up, Sylvie. Oh, look at her. Okay, so I have my calculator and I'm going to go through the steps to put in the values. So remember, I'm going to go a little fast because I feel like at this point we all are comfortable finding the linear regression. Agreed? All right. So we're going to get started. So the first thing I'm going to actually do is turn on my stats, my mode. And I'm going to go to stat diagnostics because that's just an extra tool to help me when I'm finding the regression model of a linear to know if I'm on the right track. So I'm going to go ahead and turn that bad boy on. So we go to mode and then arrow down to where it says stat diagnostics. Do we see it? All right, now we're going to go to stat, edit, and we're going to put in our values. So our values are pretty simple. We're starting off with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then our Y values, our outputs are 2, 1/10, 3, 1 and 2/10, 3 and 6/10, 3 and 2/10, and 4. Okay, so L1 is our X coordinates, L2 are our Y coordinates. We've input that in. Now we're going to go to Y equals. And I know it says that it wants you to, it wants you to go to second Y equals, go to 1, and it's just going to have the scatter plot. It's already on. So just going to Y equals and pressing enter is the shortcut. This is the long way of doing it. Does that make sense? So you either can go to Y equals and just make sure the plot is turned on. So when you first go to Y equals, notice your plot is in bold, but if you arrow up and hit enter, it's going to turn on your plot. And that's the same thing as doing second Y equals. All right. One thing that I don't like that these notes didn't include is for you to go to zoom. And we're going to go to stat because we're analyzing data. So zoom stat is 9. And it's going to show me my point. Do you see them? Yes.
What's the shortcut for the find put in underscore, right? Why?
Are you talking about second? You're talking about second trace? An alpha trace? Oh, alpha trace. All right. So now we're here. Now we're going to run our regression model. So we're going to go back to stat, calc, and we are running a linear regression. So linear regression is 4. And it's asking you, do you want L1, L2? Are those your X and Y's? Yes. To store. The shortcut to get to the store, you can follow the steps in the notes, but the shortcut is alpha traits. And I'm going to store it as Y1. And we're going to hit enter. And it's going to do its thinking. It's like, okay, boom, bam. Here's your best fit we can do with what we got. Now, the reason why I had you turn on our stat diagnostic, looking at our numbers for our R, is that a really good fit? Like just the R, not the R squared. Look at our value of our R. Is that it? Does this represent a good fit? Not really, because we want that R value to be closer to what? 1. We want to be closer to 1. And as of right now, these R squared and R value is nowhere near, like they're not very close to 1. But when we looked at our scatter plot, we knew from a start, was this going to be a perfect fit? No, we can look at these values and see that this is probably not a linear model or a linear fit. All right. Don't let your knowledge of things that you already have go out the window. Okay. You can look at a scatter plot and tell me if a linear model is the best model. But you have those other backups and those other information to help you determine that as well. All right. We're going to now look at the residual plot. So if we want to see our residual plot, you are going to have to do a little bit different. We're going to go now to plot 2. So to get to our plot, we're going to press second, y equals, and we're going to go to plot 2. And we want to look at our residual plot. So we're going to look and see what does our residual plot tell us? How are we assessing these numbers? We're going to turn it on. But to get to residual plot, do you see where it says L2? We need to change L2 to say residual. Okay. So in order to do that, we're going to press. Hold on, I gotta remember. I'm ready to set a brain part.
Go back to plot 1. Plot 2.
We're at plot 2. Second? Yeah, second set. Okay, so I was here. I went to 2. I turned it on, and I'm changing the Y list to say residual because I want to measure my residual. In order to measure my residual, we're going to press second stat. So we're going to press second stat, and you should see the word RESID. Do we see that? Okay, that's what we want. We're going to replace that. And by replacing that, we now can go, I'm going to go to Zoom, and I'm going to go to Zoom. I now have new data, new stats that I want to look at, and I'm going to press Zoom 9. And now it's going to show me all of my statistical data. I now see my scatter plot. I now see my residual plot. And when we're analyzing the residual plot, if you remember from Algebra 2, we want it to be evenly distributed above and below that positive x-axis, right? All right. So when we look at this, this is not necessarily unevenly, but it's pretty heavy in the bottom. We don't have a lot of points. But looking between this data set, we can also verify that this is not the world's best fit. Okay. What they want you to be able to do for the AP Pre-Cal test is be able to read the data, read the plot. So if you see this residual plot, you're like, it's an okay fit. It's not the world's best fit, but that's what it wants you to be able to say. And that's because the data is not evenly distributed above and below that positive x-axis, right? Yes. See that? Okay. There is no clear set pattern that's taking place necessarily. I can say, okay, this looks like it's going to be maybe a little bit more cubic or any of that. Yes. However, it's just saying, is a linear model the best fit here? Is this the line of best fit? No. I mean, this is the best it's going to get, but is it a good representation of this data? No. Okay. Do you understand how that works and how the residual plot works? Do we remember this a little bit from Algebra 2? Yes.
So why is it saying 9 residual?
Because the notes were probably made with the older calculator, well, newer calculator that has more options.
Oh, yeah. This one's 7.
Yes, that's why I said we're only look for the word, not the number.
Okay.
Yes. All right. So as we look through it, so when we were analyzing our scatter plots, again, we want a random scatter. So linear model is going to be random. Non-linear is going to be created some type of U shape or an inverted U shape that's coming into play. There'll be some kind of defined pattern. And that therefore we know that it's not a linear model. Make sense? All right. All right. So as we keep going here, if we were to look at the least squares regression line and analyze the associate plot for this one. So now we have a new value, I mean a new regression. Y hat equals 8300 x plus 4/10. These residual line segments fall above and below the regression line. What does this tell you about the values? So in order to do that, we're going to determine, are they evenly sparse? Like what's happening with our regression model? So we are here, we're here, we have here, here, this was almost on it, and we have here, right? If I'm above the regression, what does that mean? What kind of estimate is that? Underestimate. If I'm above, it's going to be a underestimate. And in your brain, you're like, but I'm above. I know. Ignore it. Okay. And if your residual is below, what does that mean? It's going to be an overestimate. Okay. So what does this tell you about your values of your residuals? And that's what it wants. Well, I should have wrote it there. My bad, guys. Okay. If I'm an underestimate, what is my sign? If I'm an underestimate, so if my p-value if I'm an underestimate, am I going to have a positive or negative, or it's going to be positive? Because that means P is smaller than A, right? Okay. Okay. My computer just decided to play music again. If I'm an overestimate,
It would be negative.
then it's going to be a negative residual. I don't know. Just hit the mute or okay. And obviously, if I am 0, then it's what? 0. Do I need to write that? No. I was going to need to write 0, 0. Okay. So underestimate means that you have a positive residual, and overestimate means that you're going to have a negative residual. Agreed? All right. So moving on, this is just another way that it can be formatted and the question can come to you. It says, how do we know if your predicted line overestimate or underestimate our data? Use a residual plot of the data set to complete the statement. So the predicted line will be blank data when the residual value is positive. What's the word? Taking what we wrote here, writing it in another way, writing it in a formal sentence. Which one of our options goes in this one? Underestimate. If I can spell, help. There we go. And therefore, the predicted line will be an overestimate data when a residual plot is negative. Okay, so knowing this, looking at this residual plot, how many underestimates do we have? So analyzing this one, how many underestimates? Underestimate. We have 3. And why do we know we have 3? They're above and it's positive. That means it's positive, correct? Okay, so we have 3. And how many overestimates do we have? Also 3, because this technically is not 0. Okay, so this is a good model. It's almost evenly dispersed, right? Oh, okay model, doable model. It's an easy brain usage. All you're doing is adding and subtracting. Is that not correct? All right, so I'm gonna let y'all tell me. We're going to do it in the calculator. So we're gonna allow the calculator to do the math, the work for us. Does that make sense? It's gonna find our regression points, it's gonna find our residual points, and it's going to do the math so that we don't have to. All right.